Good evening, my dear students. As we know that we are discussing the assignment 1. So, this is question number 5. Apply mesh analysis and determine the loop current I1, I2 and I3. So, as we know that what is mesh and what is loop. So, now I am going to explain what is mesh. So a mesh is a loop that does not contain any other loop within it. So you can concentrate here the black, it is loop and mesh. What is these two terms mean? So I have taken one simple circuit. Assume this is your circuit or network. So loop means it is a closed form of a circuit. Anyway, you can make a closed form, so that can be considered as your loop. So like this, you can go from A, B, E, F and come back to A. This is a closed form. So it is your A, B, E, F, A. This is your loop. Similarly, if you start from B, C, D, E and come back to B, it is also a closed form. So this is also a loop. And if you go from A, B, C, D, E, F and come back to A, this is also a closed form. So it is, these three are known as loop of a network. Then what is mesh? Mesh is a closed form of network which further cannot be divided into a loops. So like that, A, B, E, F, A, it is a closed form which cannot further divide into a loop. Similarly, B, C, D, E, B, it is a closed form of a network which cannot divide it further into a loop. But if you see A, B, C, D, E, F, A, this is not a mesh because it can again further divided in these two parts, this part and this part. So this one is only a loop and it is not a mesh. Now coming back to the numerical problem. So step number 1. First of all, whenever this type of analysis you have to do, you must do starting with finding the meshes first. So here mesh 1, this is mesh 2 and this is mesh 3. I have indicated in red mark. So step number 2, assume the mesh current. So assume the mesh current, you can take the directions of mesh current in any way basis on your direction of the current assigned in the circuit. You have to write your KVL equation. So I have taken this clockwise direction is my current direction of each and every loop's current, and I must tell the analysis, that means mesh analysis, is based on loop current. First of all, we will calculate the loop current, then we will calculate the branch current. So here it is being calculated the branch current in terms of loop current. So I must say in this numerical you will learn how to calculate the loop current. So first of all, come to the step number 3. Step number 3 says that use KVL and Ohm's law to write the mesh equation. So this is my first mesh and this is the assumption. When we are considering first mesh, the current corresponding to the first mesh is always greater than other two mesh current. So I1 greater than I2, also I1 greater than I3. And if you write the mesh equation, so you will get this equation number 1 for mesh number 1. Similarly, for mesh number 2, what is the assumptions? I2 current will be greater than I1 as well as I3. So here in the red box you can see I2 greater than I1 and I3. Then you apply KVL to write the equation, mesh equation. So for the mesh number 2 you will get this equation, 10I1 minus 20I2 plus 10I3 is equal to 100. I have already mentioned here. For the mesh number 3, that is I3 greater than I1 and I2, and if you see that equation for mesh number 3 will be this, 10I1 plus 10I2 minus 40I3 is equal to 0. So here one thing you have to remember, when you are writing the intermediate branch equation for a particular loop, so this loop current will be always greater than the corresponding others loop current. So by solving further, that is from equation 1, 2 and 3, I can write this matrix equation of current. Okay, so this is, I have assumed this is A matrix, this is X and this is C. Now for solving purpose you can solve I1, I2, I3, that is mesh current, in different way. You can directly put that total equation 1 and 2 and 3 in your calculator to get the answer. Otherwise you can apply Cramer's rule. So I have applied here Cramer's rule to determine I1, I2 and I3. So Cramer's rule, you know that for current I1, for current first current I1, I have to replace this constant C in the first column. For current I2, I have to replace this constant term in second column. For I3, I have to replace the C matrix in third column, and I have to divide the determinant of the original matrix, that means this A matrix determinant. So if I do, I1 will be your 4.5 ampere. Similarly, in similar way you can also calculate I2 and I3. That means for I2 we have to replace this constant term in the second column, and you have to take the determinant with this, and you have to divide that determinant to the original matrix determinant. You will get I2. Similarly I3 you can also easily get. So this is your answer, loop current answer. I1 is equal to 4.5, I2 is equal to minus 2.5 ampere, and I3 is equal to minus 0.5 amperes. So this is your question number 5. Thank you very much.